Table 220.84 of the National Electrical Code (NEC) provides an optional calculation method for determining the service or feeder load of a dwelling unit. This table is most applicable when dealing with multiple dwelling units supplied by a single feeder. It's essential to understand how to apply this table correctly to ensure accurate load calculations and proper electrical system design. The primary purpose of Table 220.84 is to allow for a reduction in the calculated load based on the understanding that not all dwelling units will be drawing their maximum power simultaneously. This is particularly useful for apartment buildings, condominiums, and, as in this case, multiple single-family homes fed from a common source. The table provides demand factors that can be applied to the total connected load of the dwelling units. Article 220 Part Roman 3 of the NEC outlines the general requirements for calculating branch circuit, feeder, and service loads. While these sections provide fundamental principles and methods, they don't specifically address the scenario of multiple dwelling units with the same level of detail as Table 220.84. Therefore, when you're calculating the demand factor for several dwelling units, relying solely on Article 220 Part Roman 3 might lead to a more conservative and potentially oversized electrical system design. This is because Article 220 Part Roman 3 provides general methods for calculating demand factors, but it does not account for the diversity in usage that is inherent when multiple dwelling units are connected. Table 220.84 allows you to take advantage of this diversity. When using Table 220.84, you must first determine the total connected load for all the dwelling units being supplied. This involves summing up the loads of all general lighting, small appliance circuits, laundry circuits, and any other permanently connected appliances or equipment within each dwelling unit. Remember to include all loads calculated according to Article 220 Part Roman 3 for each individual dwelling unit before applying the demand factors from Table 220.84. After determining the total connected load, refer to Table 220.84 to find the appropriate demand factor. The demand factor will vary depending on the number of dwelling units being supplied. For example, if you are supplying 4 dwelling units, the demand factor listed in Table 220.84 will be different than if you were supplying 8 or 12 dwelling units. The more dwelling units you supply, the lower the demand factor will typically be, reflecting the increased diversity of usage. Once you have identified the correct demand factor from Table 220.84, multiply the total connected load by this demand factor. The result is the calculated demand load for the feeder or service supplying the multiple dwelling units. This demand load is the value you will use to size the feeder conductors, overcurrent protection devices, and other components of the electrical system. It is important to note that Table 220.84 is an optional calculation method. You are not required to use it. However, it can often result in a more accurate and cost-effective electrical system design compared to using the general methods outlined in Article 220 Part Roman 3. The NEC provides this optional method to account for the diversity of loads in multiple dwelling unit installations, which can lead to a reduction in the overall size and cost of the electrical system. Before using Table 220.84, make sure to carefully review the specific requirements and limitations outlined in the NEC. Understand the conditions under which it is permitted to be used and any restrictions that may apply. For example, some local jurisdictions may have amendments to the NEC that affect the use of Table 220.84. Ensure that you are complying with all applicable codes and regulations. Additionally, consider any specific characteristics of the dwelling units being supplied that may affect the accuracy of the load calculation. For example, if the dwelling units have unusually high loads, such as electric vehicle charging equipment or large HVAC systems, it may be necessary to adjust the load calculation accordingly. It's also vital to perform regular load monitoring to ensure that the actual load on the feeder or service does not exceed the calculated demand load. If the actual load consistently exceeds the calculated demand load, it may be necessary to upgrade the electrical system to prevent overloading and potential safety hazards. In summary, when calculating the demand factor for multiple dwelling units, Table 220.84 offers a more tailored and potentially more economical approach compared to the general guidelines in Article 220 Part Roman 3. This table is specifically designed to address the diversity of loads in such scenarios, allowing for a more accurate assessment of the overall demand. Always ensure that you adhere to the NEC guidelines and any local amendments, and regularly monitor the load to maintain the safety and efficiency of the electrical system. When applying Table 220.84, the NEC stipulates several critical factors that must be considered to ensure accurate and safe electrical system design. These factors directly influence how the demand factors are applied and the subsequent sizing of feeders and service equipment. Firstly, it's essential to accurately determine the total connected load for each dwelling unit. This involves the comprehensive assessment of all electrical loads, including lighting, receptacles, appliances, and any fixed equipment. The NEC provides detailed methods for calculating these loads in Article 220 Part Roman 3, which should be meticulously followed. For general lighting, the NEC specifies a minimum load based on the square footage of the dwelling unit. Small appliance circuits, which serve kitchen and dining areas, require a minimum of 220 amp circuits, each calculated at 1500 volt amps. Laundry circuits also require a dedicated 20 amp circuit calculated at 1500 volt amps. Any permanently connected appliances, such as water heaters, ranges, and HVAC equipment, must be included in the total connected load calculation at their nameplate ratings. Secondly, understand the specific requirements of Table 220.84 itself. The demand factors provided in the table are based on statistical data regarding the typical usage patterns of dwelling units. These factors are applied to the total connected load to estimate the maximum demand that the feeder or service will likely experience. The table is structured to account for the diversity of loads, meaning that not all dwelling units will be drawing their maximum power simultaneously. This allows for a reduction in the overall size of the electrical system, resulting in cost savings and improved efficiency. Thirdly, consider any additional loads that may not be adequately addressed by Table 220.84. For example, if the dwelling units have electric vehicle charging equipment, the additional load must be carefully evaluated and included in the calculation. The NEC provides specific guidelines for calculating the load of electric vehicle chargers, which may require separate demand factors or load calculations. Similarly, if the dwelling units have large HVAC systems or other significant electrical loads, these must be taken into account to ensure the electrical system is adequately sized. Fourthly, be aware of any local amendments or regulations that may affect the application of Table 220.84. Many jurisdictions have local codes that modify or supplement the NEC requirements. These amendments may include specific rules regarding the use of demand factors, the calculation of loads, or the sizing of electrical equipment. It is essential to consult with the local electrical inspector or building department to ensure compliance with all applicable codes and regulations. Fifthly, ensure that the feeder and service conductors are sized appropriately based on the calculated demand load. The NEC provides tables and guidelines for determining the ampacity of conductors based on their size, insulation type, and installation conditions. The conductors must be sized to carry the calculated demand load continuously without exceeding their temperature rating. Overcurrent protection devices, such as circuit breakers and fuses, must also be sized appropriately to protect the conductors from overload and short-circuit conditions. Sixthly, regularly monitor the actual load on the feeder or service to verify the accuracy of the load calculation. This can be done using a variety of methods, such as installing a recording ammeter or using a power quality analyzer. If the actual load consistently exceeds the calculated demand load, it may be necessary to upgrade the electrical system to prevent overloading and potential safety hazards. Load monitoring can also help identify any unusual or unexpected loads that may be affecting the electrical system. Seventhly, document all calculations and assumptions used in the load calculation process. This documentation should include the total connected load for each dwelling unit, the demand factors applied, the calculated demand load, and the sizing of the feeder and service conductors and overcurrent protection devices. This documentation will be helpful for future reference and can also be used to demonstrate compliance with the NEC and local codes. In addition to these factors, it's important to consider the long-term reliability and maintainability of the electrical system. Choose high-quality electrical equipment and components that are designed to withstand the rigors of continuous operation. Ensure that the electrical system is properly grounded and bonded to minimize the risk of electrical shock. Provide adequate access to electrical equipment for maintenance and repairs. By carefully considering all of these factors, you can ensure that the electrical system for multiple dwelling units is safe, reliable, and efficient. The proper application of Table 220.84 combined with sound engineering practices will result in a well-designed electrical system that meets the needs of the occupants while minimizing the risk of electrical hazards. When performing load calculations for dwelling units, it is essential to accurately account for all potential loads, including general lighting, small appliances, laundry equipment, and permanently connected appliances. The NEC provides specific guidelines for calculating these loads, which must be followed to ensure the electrical system is adequately sized. For general lighting, the NEC specifies a minimum load based on the square footage of the dwelling unit. This load is intended to cover the lighting needs of the occupants and is typically expressed in volt-amps per square foot. The specific value varies depending on the type of occupancy and the lighting requirements. Small appliance circuits, which serve kitchen and dining areas, require a minimum of two 20-amp circuits. Each of these circuits must be calculated at 1500 volt-amps for a total of 3000 volt-amps. This is intended to provide adequate power for the various small appliances that are commonly used in these areas, such as toasters, blenders, and coffee makers. Laundry circuits also require a dedicated 20-amp circuit, which must be calculated at 1500 volt-amps. This is intended to provide adequate power for washing machines and dryers. Permanently connected appliances such as water heaters, ranges, and HVAC equipment must be included in the load calculation at their nameplate ratings. The nameplate rating is the maximum power that the appliance is designed to draw under normal operating conditions. In addition to these basic loads, it is important to consider any other potential loads that may be present in the dwelling unit. This may include electric vehicle chargers, large HVAC systems, or other significant electrical loads. These loads must be carefully evaluated and included in a load calculation to ensure the electrical system is adequately sized. The NEC provides specific guidelines for calculating the load of electric vehicle chargers, which may require separate demand factors or load calculations. Similarly, if the dwelling units have large HVAC systems or other significant electrical loads, these must be taken into account to ensure the electrical system is adequately sized. Once all of the potential loads have been identified and calculated, they can be added together to determine the total connected load for the dwelling unit. This total connected load is then used to determine the demand load, which is the maximum amount of power that the dwelling unit is likely to draw at any given time. The demand load is typically less than the total connected load due to the diversity of loads and the fact that not all appliances will be operating simultaneously. The NEC provides various methods for calculating the demand load, including Table 220.84, which is specifically designed for calculating the demand load for multiple dwelling units. When using Table 220.84, it is important to follow the specific instructions and guidelines provided in the NEC. This includes understanding the limitations of the table and ensuring that it is appropriate for the specific application. In some cases, it may be necessary to use a different method for calculating the demand load, such as the general methods outlined in Article 220, Part Roman 3. Regardless of the method used, it is essential to carefully document all calculations and assumptions. This documentation will be helpful for future reference and can also be used to demonstrate compliance with the NEC and local codes. By accurately accounting for all potential loads and following the NEC guidelines, you can ensure that the electrical system for dwelling units is safe, reliable, and efficient.